Now we will move on to perpendicular lines. If you've understood the beginning of the lesson with parallel lines, then perpendicular lines follow the same method, except there's a slight change in the gradient, which I will show you. So what are perpendicular lines? Perpendicular lines are when two lines, they meet each other and they have a right angle between them. And what's significant about their gradient? Well, for example, if the equation of one of them is, let's say, y equals 3x plus something, let's say 5 or something like that. Let's just call it c for now, because that could be any value, all right? Then the gradient of this one currently is 3. So what would the gradient of something that is perpendicular to this be? It will be the negative reciprocal, which simply means minus 1 over whatever the gradient of this one is will go here. So in this case, it's 3. So it will be, the equation of this would be y is equal to minus 1 over 3x plus something. Again, that something can be any number, any value. So that's what it means when two lines are perpendicular to one another. Let's practice this some more. So if the gradient of something, let's say, is 2, the gradient of a line which is perpendicular to this will be minus 1 over whatever the gradient of this one was, which is 2, and just put the 2 there. So it's minus 1 over 2. Let's try this again. So let's say the gradient of something is minus 3. So therefore, the gradient of something which is perpendicular to this would be minus 1 over the negative reciprocal, and you'll just insert the minus 3 here. So minus 3. Now this, two negatives here will give you a positive gradient overall. So you get 1/3. If you apply this to fractions, so for example, 2 over 3 is the gradient of one line, and the line which is perpendicular to that would be minus 1 over, and you put this fraction in, so 2 over 3. Now here you have a fraction over a fraction, so you know what to do. You take the number here and you multiply it at the top, giving you 3 times 1, which is 3 over 2, and say negative overall. So the gradient of this one would be minus 3 over 2. Now you may have noticed a pattern in terms of the sign. See, you had a positive gradient here, and the line which is perpendicular to that had a negative. And vice versa. If you start off with a negative, then the line which is perpendicular to that has a positive. And if you look at this fraction, you'll also notice that when you have a fraction as a gradient, the end result is just a flip of these numbers, so the 3 over 2. And of course, you've got the positive going into a negative. Let's practice this on another fraction so you can see this in action. So if you have minus 7 over 2, for example, the line which is perpendicular to this will have, first of all, it's a negative here, so it will be a positive overall. And it's a fraction, so you just flip the numbers. So 2 over 7 would be its gradient. Now that you've had time to practice this, let's apply it on a very typical question that you will get in an exam paper. Find the equation of a line that is perpendicular to x plus 2y is equal to 6, and it passes through 1, 9. So let's get rid of this here. Right, so what's it saying? It's saying there is a line, and this line is x plus 2y equals 6. And there is a point. Let's say the point is, I don't know, right here, 1, 9. And this other line is going through this point and is perpendicular to this line. So this equation that it wants me to find is of this line. Sorry, it's not very straight. Do forgive me for that. So I want to find the y equals to mx plus c of this line right there. First of all, I can find this straight away using what I've just shown you. I just have to get the gradient from here. But this is not written in the y equals mx plus c form. So I have to get this into the y equals mx plus c by making y the subject. So how do I do that? I take the x over to the other side. So I get 2y is equal to, I could write 6 minus x, or I could write minus x plus 6. It's the same thing. Then I divide by 2. So I get y is equal to minus 1 over 2x plus 6 over 2 is 3. So what is the gradient of this line right there? The gradient of this is minus 1 over 2. Now if we do what we did previously, so m1 would equal minus 1 over 2. Therefore m2, which is the line which is perpendicular, and this line, its gradient would be positive first of all, and it would be a fraction, so 2 over 1. So you could write 2 over 1, but you know 2 over 1 is the same as writing 2. So I can go in here and I can replace this m with 2. So I can have y is equal to 2x plus c. And just as we did with the parallel lines, we just need to find the value of c by substituting the point that it goes through, which is 1, 9. So I can just sub in 9 here for the y, 2 times the x, which is 1, plus c. So I'm going to find c now. So I get 9 is equal to 2 plus c. Take the 2 to the other side. So 9 minus 2 is 7. And therefore c would be equal to 7. I go back here and I'll replace this with my 7. So the final equation of this line would be y is equal to 2x plus 7. And I have answered the question. This is the equation. Now on to this next question. Another type of question you may be asked is to show when lines are perpendicular to each other. So here we have a question which says show which two lines are perpendicular, and we've been given the equation of 3 different lines. It's no problem. We know how to find the perpendicular by looking at the gradient. So if we were to look at the gradient of each of these, we will be able to tell which ones are perpendicular, because they will be the negative reciprocal of the other. At the moment, as it stands, none of them are in the form that I want it, which is y equals mx plus c. So what I'm going to do is put them all into that form. So starting with this one, we've got 8y minus 4x is equal to 3. I want to have y on its own, so I'm going to take the 4x to the other side. So I get 8y is equal to positive 4x plus 3. So therefore, I'm going to be dividing by the 8 now. So 4 over 8 is a half. So therefore, half x, and 3 over 8 is remaining as 3 over 8. So the gradient of this one is a half. So let's write this down. M is equal to a half. Moving on to this one, I've got the y here, so I want the y to be positive, so I'm going to take the 2x to the other side. So I'm going to have y is equal to minus 2x plus 8. I don't need to divide by anything. What's the gradient of this one? The gradient is minus 2. So therefore, I've got m is equal to minus 2, which I will just mark. Now, we can already see that they have some sort of relationship, but we will just check it and make sure that this doesn't have any relationship. Again, we'll put this into y equals mx plus c. So we've got the minus 6y here. We want to make it into a positive, so we're going to move over to this side. So we get 5x minus 3 is equal to 6y. Now, of course, you can start off by writing 6y is equal to 5x minus 3, because that helps you form that image of y equals mx plus c in your head. And then you divide by 6. So you get y is equal to 5 over 6x minus 3 over 6, which is a half. So what's the gradient of this one? The gradient is 5 over 6, which has no relationship or correlation with the other two in the sense that they're being perpendicular or parallel. So just to prove that these are the negative reciprocals, we know that if we take, for example, m1 as minus 2, therefore m2 will be minus 1 over minus 2. And then you get a positive because you've got the signs negative and negative, and it's a positive half. So therefore, they are the lines which are perpendicular. Something else you can also do is m1 times m2. And you might see this in the books. If the gradient of the first one times the gradient of the second one gives you minus 1, then that is also proof that they are perpendicular. So you could quickly try this. So m1, let's say this as m1 is a half, times by m2, which is, this one. This should be m2, it's coming from there, remember? So minus 2. So therefore, look, and 1 times the negative here, it just leaves us with minus 1. Hope you enjoyed this lesson. If you like this video, please give it a thumbs up. And if you haven't subscribed already, please subscribe. It helps the channel grow. It keeps us motivated to produce more content like this for you. See you in the next video, guys. Goodbye for now.